Hello, good day viewers. In this partial class, we're going to look at one particular proof here that has to do with an equilateral triangle. I want to show that the sides of equilateral triangle, they are 2 units each, and any altitude, that is any line that's cut from any of those vertices to meet the middle of the line opposite it, they are root 3. So that's what we're going to prove here. Now remember, in a equilateral triangle, all the sides and not all the angles, they are, all the sides, they are the same, and all the angles, they are 60 degrees each. Okay, so here it is now good to say that line AB is equals to line BC is equals to line AC. AB, BC is equals to, they are all the same. Okay, so here we can also see that this point here, D1, D2, and D3, they are the midpoint between AB, the midpoint is D3, between BC, the midpoint is D1, between AC, the midpoint is D2. So for instance, if we decide to pull out one of the triangle, let's assume we decide to pull out here A, B, and D1, for instance. Okay, so it means that from this line here AB, this line here AB is BC and is equal to AC. So we can also say that this is half of this line here, B, D1 is half. Okay, this is half of BC, right? It's also half of what? BAC, since they are all equal. So that's what BD means, it's half. Half of what? We can say it's half of A, the line AB. Since AB, BC, and AC, they are the same. So we can confidently also say that the line, this line here, line AB is 2 times the line BD1. Okay, 2 times the line BD1. That is the implication here. So now, if we look at this triangle here, if we look at this triangle ABD is a right angle triangle. So that means we can apply the Pythagoras theorem here. So we're going to make use of Pythagoras theorem here. By looking at this triangle, we could say that since this is the hypotenuse, the side facing this will be right angle, we say here that AB, line AB square is equals to the line BD1 square. BD1 square plus the line AD1 square. AD1 square. That is for using Pythagoras theorem here. Okay, so simply, since we have already made some adjustment by saying that the line AB is 2 times BD1, 2 times BD1, so we can now correctly say or substitute in place of AB 2 BD1. So this will be 2 BD1 square it. This will be BD1 square plus AD1 square. Okay, AD1 square. So if you square 2 BD1, this will give 2 square. Here we square each of those item or each of those expression within this bracket. So this become 4 BD1 square. 4 BD1 square. Then quickly let's move this BD1 here to the left hand side. This become minus the line BD1 or square is equals to line AD1 square. Now 4BD1 square minus BD1 square, what will be left there is 3BD1 square is equals to the line AD1 square. Now we have to remove this square because we are trying to establish, look for this line here, AD, which is, okay, the line AD here, and the line B, line AD1, the line BD2, and the line CD3, they are the same. They are the same, okay? Now, here, if we do that, we have to apply the square root to remove this square. So, I'll take the square root of both sides. This becomes square root of 3, then the line BD1 square is equals to the square root of the line AD1 square. Now the square will take care of this, the square root here will take care of this square and the square here. And here become root 3 times B, the line BD1 is equals to the line AD1. Okay? Now all we need to do, because we are looking for this numerical value for AD1 and BD1. So let's quickly divide both sides by the line BD1. So divide both sides by the line BD1. So here we go with this. So what we have here is root 3. Remember, we can also say that this one is over 1 is equals to the line AD1 over the line BD1. Okay, so now the line, you can see clearly here that the line AD1, which is the altitude, that is the line from here to here, like we said, we want to show that this line here, or from here to here, or from here to here, they are all root 3. So you can see here clearly by comparison, the line AD1 is root 3. Okay, so the line BD1, let's look at the line BD1. The line BD1 is equals to 1. But we are also looking at that we want to also show that AB is 2 centimeters, BC is 2 centimeters, and the AC is 2 centimeters. But we recall, if you go back here, we said that the line AB is 2 times the line what? BD1. So since BD1 is 1, the line AB is 2 multiply 1, which also give 2. Okay, so clearly now since we have said that the line AB is the same thing as the line BC is equal to the line AC. So we have been able to show that given an equilateral triangle, that all the sides, they are equal to 2 units, but the altitude, that is the line that crosses from each of those vertices to hit the middle of the other two lines, they are equivalent to root 3. So please, if this video is very useful to you, help me subscribe, like, comment, and follow my page. There are some comments that you want me to do on how to improve better. Please do not hesitate to drop them on the comment section. See you in my next class.